All right, welcome to section 8.1 where we're looking at functions and their representations. I'll work a few exercises here. All right, so first one here, determine if the following operation describes a function. Finding each person's daughter in a family. Okay, well that one, first off, really doesn't make much sense, and each person's not going to have a daughter, and so it's not going to be actually a function. So in this case, we'll say no. What about here? Evaluate f of x at the given values of x. So we have f of x is equal to the square root of x, and we're supposed to plug in x is 0 and x is 49 over 16. So f of 0 is equal to what? Well, that's the square root of 0. Well, that's just 0. What about the other one? F of 49 over 16. Well, that's the square root of 49 over 16, which we can rewrite as the square root of 49 over the square root of 16. Well, the square root of 49 is 7, the square root of 16 is 4, and so that would be our solution to that one. Okay. Here's another one where we're supposed to evaluate f of x at the given values of x. So f of x is equal to 7, and we have x is negative 13, and x is 5 halves. All right, so here we have f of negative 13. Well, there's no x value, so it's still just 7. And same thing goes for when we plug, 5 halves, it's just 7. This is a constant function is what it is. If we had a variable on here, then we'd have to multiply or divide or whatever we have to do. But since we don't have the variable, it's just a constant function, and our answer is always going to be 7 no matter what. All right, here this one's a little bit different though, because now we have f of x is 5 over x plus 3, and we're supposed to plug in negative 13 and 3. So f of negative 13, and we also want f of 3. Well, when we plug in negative 13, we get 5 over a negative 13 plus 3. Well, that's going to be 5 over what? Negative 10. Well, 5 over 10 is a half, so it's going to be a negative 1 half. What if we plug in 3? Well, then we have 5 over 3 plus 3. Well, 3 plus 3 is 6, so we get 5 over 6. All right, let's pause there and we'll come back for some more.